Alright, these are our notes on trapezoids. The trapezoid is a quadrilateral which means that it has four sides if it's a quadrilateral, with one set of parallel sides. Okay, only one. The equation to find the area of the trapezoid, I'm just going to give to you right off the bat today. Is half of the height times base 1 plus base 2. Okay? I'm going to demonstrate why that equation is what it is. Okay? So I have a trapezoid here. And what I'm going to do is I'm going to duplicate that trapezoid. Okay? And I'm going to flip it. So we have on the original trapezoid, this is base 1, and on the bottom is base 2. Now that I flipped it, together here, this is base 1, and this is base 2. Okay? Notice what shape the whole thing, when put together, makes. It makes a parallelogram. And we know that I can take this parallelogram and cut it right there and put this piece over here, and I'm going to form into a rectangle. So we know the equation for a rectangle is base times height. So that's where this formula originates off of, from the base times the height. Okay, if I take and add B1 and B2 together, that basically gives me the base of a rectangle. Okay, but if I want to find the trapezoid, it's only half of it. So I would take that base times height and divide it in half. Okay, to give me the area of the rectangle. I'm sorry, the area of the trapezoid. Okay, so now in your own words, explain why that equation is what it is for a trapezoid. Okay, going on to examples and calculating. Again, that equation is area equals 1/2 of the height times B1 plus B2. Okay, I told you B1 is the top, B2 is the bottom, and honestly, if you get these switched, it's not going to make a difference. Okay, our height is always the straight side of the trapezoid. Okay, do not use an angled side for the height if it were to have a measurement on it. Okay, so I'm going to identify again, B1 is equal to 8, B2 is equal to 14, and the height is equal to 6. If I plug that all in, 1/2 of the height times B1 plus B2, and then I'm going to solve through this. 1/2 times 6 is 3, and 8 plus 14 is 22. So when I multiply through, I get 66, and my units are feet squared. Okay? Looking at our next trapezoid, looks slightly different. Okay, this is more of the common trapezoid that you see. You can't call it regular because it's not equal-sided and equal angled, but it is a more common trapezoid that you see than the one that I had on example 1. Okay, identifying B1, B2, and the height. Okay, B1 is the top, B2 is the bottom, and our height, remember, is the straight side, not the angle. Okay, this gives you a misconception on what the actual height is. So B1 is 13, B2 is 29, and the height is 13. So if I plug that in, 1/2 of the height, oops, I'm sorry, I switched. I miswrote that number, 15. And times B1, which is 13, plus 29. Okay, for me, you could either multiply by 1/2 and get 7.5 for 15 times 42. If you don't like the decimal, you could do all of the multiplication and addition first and then multiply by 1/2. Either way, you're still going to get to an answer of 315 inches squared. Okay, on your paper, you've got 2 more examples. Okay, solve those 2 examples and also make sure that you fill out the part where I'm asking you to explain in your own words why the equation for a trapezoid is what it is.